Okay, we're going to look at vertical asymptotes and behavior around vertical asymptotes on functions. So the topic of vertical asymptotes comes up with rational functions because, as you notice, when there's variables in the denominator, it's possible for that denominator to get zeroed out. And when that happens, you either get a vertical asymptote, asymptotic behavior, or possibly, not in this case, but possibly a hole in the graph, which we call removable discontinuity. Talk more about that in pre-calc, not just algebra 2. For starters, let's look at the graph of this, because whenever the word behavior comes up, I think it's important to remember that they're talking about asymptotic behavior. And, well, actually, before I look at the graph, asymptotic behavior, you actually hear people use the word asymptotic in other conversations from time to time. But if you've got a vertical asymptote, I'm just speaking in generalities here. Asymptotic behavior means as you get closer to that asymptote, it gets very, very high, very, very tall, or possibly very, very low, spiking towards negative infinity. So just in a real general sense, this is just an example. When we're talking about asymptotic behavior, we're talking about, is the function spiking upwards on the left side of the vertical asymptote and downwards on the right side? Or is it the other way around? Or maybe are they both spiking upwards no matter which side you approach from? So you can kind of see in the descriptions, or I should say the multiple choice answers here, they talk about from which direction you're coming from. All right. So we'll get some fancy notation down the road to handle this. But for starters, why don't we go to the grapher? If we were doing this in class together, we would have our graphers out. And you don't need the grapher necessarily to tell that this thing is going to have, where'd my pen go? This thing's going to have a vertical asymptote at -2, or at least some kind of discontinuity. You might want to factor that top expression and just to see if x plus 2 is a factor upstairs as well. But what do we have here? So we can break this down, factor the quadratic in the numerator, and looks like it's going to be x minus 6 times x plus 4. And none of those factors in the numerator match the x plus 2 in the denominator. So I could say confidently that there's going to be some kind of a vertical asymptote. Well, there's going to be a vertical asymptote right at x equals -2, which, the question is more or less just hinting to that already. So when we go to the grapher, be very careful to punch in parentheses around your numerator expression as well as your denominator expression. If you put this into your y equals without those parentheses around those grouped layers, you won't get the same graph you're about to see. So I'm going to hit enter and we'll graph it. Now I like to do a zoom 6, just a standard -10 to 10 window to see what we see, and then we'll make adjustments from here. Okay, so pretty good indication already that it is kind of like the example I put there with the yellow highlighter, where we're spiking up if we're approaching from the left, and if we're approaching from the right side of the graph, it does appear to be. But this mystifies people because -2 is right here. I don't know if you can see my pointer. I'm going to make the window, we've got plenty of left to right. I can see what's going on the left. I can see what's going on the right. But in terms of height, I want to be a little more convinced of this behavior. So I'm going to let the window in the y direction go quite a bit lower. Maybe I'll go down to, use my mouse here, hang on, -50. And we'll go +50. Also going to scale that by 5s just so we don't get overrun with tick marks here. So the graph is not, the function's not changed, but the graph is going to look different because we scaled that y-axis out. Okay. All right, let me pull this in and we're going to take a look at this graph. and make a selection here. All right, so lock that down. Okay, on the wording, I think that's what gets people bogged down quite a bit. Okay, when you are approaching, I'm just going to dash in a little indicator there. When you're approaching the vertical asymptote at x equals 2 from the left. From the left means, what's the left side of the graph? Well, that's over here where negative infinity is. So from the left side, as we get closer and closer to this -2 issue, the height of the graph is going boop, 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 increasing and increasing. In fact, if you trace this thing, I can open up the grapher here again, and if you hit trace and you go to -2, oopsies, -2.01. So that's pretty close to -2, but not too crazy. It's already up at a height of 1,593.99. And you're only just 0.01 away from it. What if I went -2? I get really close to -2, like 0.000. What's that? Tens, hundreds, thousands. 1/10,000th lower than -2, just to the left. Now we're up almost to 160,000. So what the wording is trying to get to is, in discussing the behavior, is okay, so let's look at option A. The graph of P approaches negative infinity from the left. No, from the left, on the left side of the graph, as we get closer and closer to -2, we see this thing not approaching negative infinity, but approaching positive infinity. So I like this first. Where did my pen go? Why does it do that? I'm sorry. Should be doing a review video for this stylus. The graph of P approaches positive infinity. Yes, positive infinity. We're talking about heights. That's what behavior is. When you approach from the left, is going higher and higher and higher. We showed that with tracing. You can see it here with the way that graph is spiking upwards. So this is the left side of the graph. If you're coming from the left, the behavior is positive infinity. When you hear behavior, think height. Okay, maybe I should make a little note of that here. Think height. Okay, let's see if the rest of option C plays out. And negative infinity from the right of the asymptote. So the right side of the graph is the positive x end of things. So if we take a ride down the graph here, approaching -2, plugging in x values closer and closer to -2, but from the right side, so from the high side of -2, your result is a height that is approaching negative infinity. So I do agree with this second piece of the statement. And you could see on option D, approaches positive infinity from the left and from the right. Well, that would be if this graph was spiking upwards on both sides, then option D would be your answer. But I'm a fan of option C. It seems to be the most accurate. Let's also do that little trace. I want to move my face again, sorry. If we go back to the window here and hit trace, and then let's punch in a value, an x value that's really close to -2, but from the right, you'd be just below -2 in terms of an x value on the number line. So -1.99, it's pretty close to -2 from the right side, and you're already at -1605.99. So if we get even closer, I mean, you saw me play this game already. Just put a few more digits of accuracy. Wow, it really spikes towards more negative and extreme values. So we can confidently say that thing has a tendency towards negative infinity. If we go infinitely close to -2, you're going to get that asymptotic behavior. All right, I hope that makes sense. Let me know, and good luck.